Okay, I'm going to walk you through how to find a method for how to find the area of a regular polygon. And I want you to start by just considering that concept. You're finding the area of any regular polygon. So I've drawn just basically the 6 most basic figures, excluding the square and triangle, for which we have other formulas for. We've got a pentagon, hexagon, heptagon, octagon, nonagon, and decagon. And you can see they get quite complicated pretty fast, and that's me just drawing basically what I can draw. Of course, we could have more sides than that. So the task is, can we actually come up with a method that would allow us to find the area of any one of these, plus others that maybe we can't even draw? And can we come up with a single method so that we don't have to draw it and be creative every single time? Certainly not the only way to do a lot of these, but here's a method that will work. We're going to start by inscribing all of our polygons in a circle, and then we're going to draw in to the center of that circle, so we've added a bunch of radii. Now consider there are different numbers of triangles. Maybe just take a quick moment, pause the video, and look and see how many triangles does each one have. What do you observe about the triangles? Okay, they look like a lot of wheels, right? We're going to simplify it in a second here. But hopefully what you're observing is that all of the triangles would be congruent isosceles triangles. And of course the number does vary as the number of sides varies. So what if we found the area of one of those triangles? Could we then multiply by a given number and get the area of the whole thing? I'm going to walk you through it. Okay, we're going to simplify. Let's go with a pentagon, because it is the easiest one to at least visualize. And we're going to start by, yes, we recognize that there are 5 triangles in a pentagon. When we're talking about regular polygons, we usually use the letter N for number of sides. So I'm going to stick with that, and I'm going to say that the area of my polygon, I'm going to use P for polygon, would be equal to the area of one of those triangles times N, the number of sides that I have. Okay, I know it's 5 in this one. I'm going to try to keep it as general as I can. Okay, let's simplify the picture a minute. Oops. Let's go ahead and delete a couple of these that we don't need. And let's just keep one of those triangles because we just established that they're all congruent to each other. So I'm just focusing on how do I find one of those triangles. Of course, I have a formula for area of a triangle. No surprise, 1/2 base times height. Now the problem is that when I'm talking about the base and the height, that's not necessarily the base and the height of my pentagon. So let's go ahead and call the base of my pentagon. I'm going to go ahead and use the letter S. S for the side length, because if we didn't have the triangle in there, you would just consider that the side length of the pentagon. Okay? There wouldn't be any triangle there. The 1/2 is going to stay in my formula. And I think we can do better with the height. The problem that I have with height is that the height of your pentagon, I would consider the height of the pentagon to actually be that, straight up and down. Okay, and that's not the height of my triangle. So mathematicians decided that they needed to come up with another word for that. So they actually started to refer to the height of the triangle in a different way. New word for you, that the height of the triangle is actually the apothem. That would be the distance from the center of the polygon to any one of the sides, distance of course measured at the perpendicular. Okay, so we've got our apothem is our height of our triangle, and then we're going to multiply that times n, the number of sides. And you can actually do it this way every single time. You can just actually find the area of the triangle. A lot of people like to do this. Hey, I'm going to find the area of the triangle, then multiply by the number of sides. Okay? One other possibility, if you prefer, we could simplify this slightly. We could say the area of the polygon is 1/2 times the apothem times, look closely, if we take the side length and the number of sides, think about it. If you take those two quantities and put them together. Remove the triangle, side length of a polygon multiplied by the number of sides. If it's a regular polygon, all the sides are equal. What did you actually just calculate? And hopefully you're saying you calculated the perimeter of the polygon. And if you look in any math, any geometry textbook, that's the formula that you're going to find for the area of a regular polygon. 1/2 times the apothem times the perimeter. Realize that's the exact same thing as finding the area of one of the triangles and multiplying by the number of sides in the polygon, which is the same as the number of triangles. We're going to be doing the same math either way. It's just a matter of how you put it together in the end that's going to change. Okay? Let's walk through two of them, and I will show you how we do this with some numbers. Okay? So, let's go ahead and get, I actually like to start with a hexagon is not too bad, so let's go for our 6-sided hexagon. Okay, I'll keep the circle there. And supposing I tell you that the side length of your hexagon is 10 inches. Again, that's the side length of the hexagon. Given information, I want to find the area, I want you to find the area of the hexagon. So I'm going to actually do it both ways. Area of the hexagon, I'll use H for hexagon, equals area of the triangle times the number of sides, and in this case, we do know that the number of sides is going to be 6. I like to go ahead and just start plugging in as quickly as I can. This is the same thing I had just a minute ago, but let's go ahead and see. The base is 10, so I'm going to put that in. So I now got 1/2 times the base times the height of my triangle times 6 is my number of sides. So my task is now to find the height of my triangle. Before I do that, I'm going to go ahead and draw in the triangle. Just try to make this look as accurate as we can. So there's my isosceles triangle that I have. And I need to find out something about that triangle to find the height. Isosceles triangles are good because we know that we're going to split that top angle in half. Okay, but I'm going to have to be a little bit creative here when I'm doing this. And I'm going to have to think, what do I really know about hexagons? Angles would be a good place to start. You can go to the exterior. You've got a couple ways of doing this. You can go to the exterior angles because we do know that, not the exterior, the interior angles of my polygon, but around the edges. We do know that those are equal to, hopefully you're remembering a formula here, n minus 2 times 180 divided by n would give me each one of those angles. Okay, plug in 6, of course, for your hexagon, and you should be getting 120 degrees. We're splitting in half, so you're getting 60 and 60. That's one way of doing it. The other way of doing it, and really my preferred way of doing it here, because it works every time, and I don't have to worry about even remembering that formula, I think about the fact that I really have how many triangles here? Thinking back to that original picture I showed you, we have 6 triangles. So how many degrees do I have total around this point? Well, I've got 360 degrees, and in this case I'm dividing by 6 to give me a 60-degree angle up here. So either way it should be working out. Hey, I've got a 60, and we just said that both of these are going to be 60. I do in fact have an equilateral triangle. It's not always going to be equilateral. Here it is an equilateral triangle. Okay? I know I kind of made a mess of my picture, but you got to think that. Going with central angle here. To find that 360 divided by n was what I divided by. Okay? I know that was a lot of work. I'm ready to find the height of my triangle, so I'm actually going to redraw just so we can see what is going on here. Let's redraw that triangle. Here was the original given length, 10. We just established that it is an equilateral triangle. I'll mark that nicely in there, and then let's go ahead and draw that height in. And when I draw that height in, I can automatically go ahead and divide my base in half. So I've got 5 here and 5 there. I want to find the height. Hopefully we're recognizing. It's our good friend, the 30, 60, 90 triangle. We have the short leg is 5. Therefore, the long leg, the height or apothem, is going to be 5 times radical 3 and that's what I'm going to put in for the height of my triangle. Again, that's what we are calling the apothem since it's not the height of the hexagon. At this point, congratulations, you have everything that you need. Go ahead and multiply it all out. You can do 1/2 of 10, or you can multiply 10 times 5 radical 3 times 6. Then take 1/2 of that at the end. Either way you do it, you're going to get 5 times 6. I'm getting 150 radical 3. And of course, we should put some units with this. We had inches, and let's go ahead and do square inches since I am doing area. Okay? Really didn't have a new formula there. We just use the area of the triangle and multiply by the number of sides. If you prefer, this is option 1. Method 1. Method 2 was the formula I told you. Area is 1/2 times the apothem times the perimeter. And I am going to show you that that works and gives us the same answer. 1/2 times the apothem, okay? At this point, I'm doing all of the work that I just did right here to figure out that the apothem is 5 radical 3. So we didn't avoid that work. I'm not going to redo it. I would have had to do everything, get the 60-degree angle, figure out the apothem is 5 radical 3, and now I'm going to have to do a little bit of work on the side here to get my perimeter. I'm going to have to do 6 times the base or side length, which is 10, to give me 60 for my perimeter that I'm going to put right in here. Okay? So 6 times 10, sorry, is giving me the 60. Multiply it out. 1/2 times 5 radical 3 times 60 is giving me the same answer of 150 radical 3 square inches. One more time. I don't care which method you use. There are 2 perfectly fine ways of doing the same problem. You are going to use that triangle that you see in there. Second one, I'm not going to finish it completely. I'm going to set it up for you so you can see how these problems may look different. I can change 2 things. Of course, I can change the shape, and that's going to affect our angles if you're following along here. It's going to affect our angles that we have up here and down there. That's also going to affect, and the other thing that I can change is I can change what given information I choose to reveal to you. In this case, the given information was the 10 for the side length. That was the only thing you did. Okay? Let's go back to our friend, the Pentagon, because that one's easy enough for me to throw on here and for us to see the triangles. And given information this time, I'm going to tell you that in your Pentagon, you know the radius is 9. Okay, be careful. Remember that radius. I can use that term in reference to a polygon now because we're establishing this as an inscribed polygon. So the radius is going to be the length from the center point out to any one of the vertices. I did not previously label that. If we go back here, I'm adding to this that this is going to be called the radius. Not new if we have the circle there. Okay? So here we are, and I'm giving you the information that the radius length is 9. That's all you know. Find the area of the Pentagon. Again, you can choose which formula you want to use, but I'm going to show you what you're going to need to do is you're going to need to use that triangle and actually find the height, the apothem at some point, and find the base at some point. I know that the angle that I have, the given angle up here, is going to be 360 divided by n, in this case 5, which is giving me 72 degrees. So I know this is a 72-degree angle. I'm now going to take that and I'm going to drop the altitude down. Of course, I have isosceles triangle here, and I'm going to redraw one of those triangles. And I'm choosing to draw this one. It doesn't matter which side you really use. And there's my right angle. So I have a given information 9 for the hypotenuse of the triangle. Angle at the top, be careful. The angle up here is not going to be 72 degrees. I'm looking at that angle, and I'm going to take this angle, which was 72 degrees, and I'm going to divide it by 2. So I'm going to get 36 degrees up there. I've got 9 for my hypotenuse, and I want to actually find both of the other 2 lengths, the apothem, this green side, and then the base down here, which is part of, be careful, part of the side of the triangle. Okay, let's walk through it. I'm going to go ahead and put an X right here. I want to use A, but A sometimes gets mixed up with adjacent, and that would be a hint that you should be thinking you have a 36-degree angle. This is not a special right triangle. It is a right triangle. Method that you're going to use to solve for X. Hopefully you're thinking good old SOHCAHTOA. I've got the adjacent and the hypotenuse, so I'm using cosine 36 equals adjacent over hypotenuse. Go ahead and grab your calculator. Do the math there. I'm going to check myself. Times cosine 36. And I'm getting X is about 7.28. Let's keep at least 2 decimal places as we're working through this, because the more we round, the more off our answers are going to be in the end. Okay, I said that you have to find this other length too. I'm going to go ahead and call that y, just use a different variable. And this time I should be looking at sine 36 equals y over 9, multiply 9 times sine 36, and I'm getting approximately 5.29. Okay, so back to this, I've got 7.26 now, right here, and I've got 5.29. Please be careful. Your 7.26 is good. That's going to be the same thing when you go over here. However, the 5.29 is only half of your base when you go over here. The side length of your triangle, or the base of your triangle, is actually going to be 5.29 times 2, which is going to give you 10.58. You should be good to go ahead and find the area of the regular polygon. You have everything that you need. Go ahead and apply your formula. Area equals 1/2 apothem times perimeter, or actually calculate the area of the triangle and multiply by 5 in this case, since you have 5 triangles, 5 sides. Okay? We will check. Actually, I'm going to go ahead and put the answer, pause the video, do your calculation, and then go ahead and check your answer. Whichever way you did it, you should be getting area of approximately 192.56 units squared, since I didn't give you any specific units to use there. Okay, we'll practice more, but that's the basic gist of finding the area of a regular polygon.